Hello. I'm making this video to go over my explanation for information and protocols in regards to computers and information systems at a very low level. I think looking at these topics in a more minimalistic way helps kind of get rid of any intimidation or overthinking or misconceptions when it comes to them. So here's my little presentation about it. There's two main things, concepts to note when regarding information. First one, I'm just simply going to refer to it as a state. Let me jump this bad boy up. Hold on. So a state is basically some way to reference and track uh, a state. I guess you're using a state so you can reference it and then interpolate information from it. That's the point of having a state, right? The second thing is, I'm gonna call it a protocol. The reason I'm using protocol is because, I mean, for one, as you'll see, it really, like, this is what it is that we're going to be talking about. But I think it's important to use something like this in such a low level context, because if you can understand this at its core, when you're referencing other protocols at higher level in computer science, you're not going to get bogged down. You're not going to be like overloaded with information, right? Just a protocol is a protocol, no matter the context. Some protocols are more advanced, like Ethernet protocol is advanced, TCP/IP is more advanced, but at the end of the day, they are just protocols. So that's why I'm choosing to just use this word for this for sake of this presentation. So here I plan on giving a sort of analogy, showing what information is and how we use it. So for the analogy, I'm using this setup here. We have a car. We have one car in question. I know there's a bunch of cars here, but just regard that for now. We have one car in question. Uh, we can say, let me grab this. We can say, well, this is us. Now, for the sake of this presentation, thought experiment, whatever, consider us to be a person with horrible memory loss. Like, we just cannot remember what we did like 20 minutes ago for the life of us. And that's just how we live our lives, right? Horrible short term memory. Let's do that. Right. However, we do have some long term memory, and in our long term memory, we have a few things of import. Now, the first one is that one, we must wash our car once a week. I guess I could say once a day, but we'll say once a week to keep it more realistic. Once a week, we have to wash our car. Doesn't matter why. Could be some like obligation we have. Maybe it's we're watching for someone. It doesn't matter. We just have to wash this car once a week. But we can never remember if we did. Right? You could wash the car and then like immediately after forget you did. Right? Because we have horrible short-term memory. So how do we go about ensuring that we wash the car? Right? Obviously, these pictures are kind of obvious. Like if the car looks like this over here, you kind of know you didn't wash it. Well, let's just say, for the sake of argument, we live in a big, tall apartment building, right? We're like 14 stories up, and we don't feel like going downstairs every 30 minutes to check if the car is clean or not, right? We need a way to track whether or not we wash the car. So for this, we're going to use a protocol. What that means is we're going to have an sort of a formal agreement of how we interpret states to translate it into information, which is what a protocol is. As you can kind of guess from these quarters right here, the state we're going to be using is a quarter, right? So real quick, let me just outline our protocol right here. Our protocol is going to have a few parts. Protocol. We're going to have step one. Here, let me do this. Step one, or I guess first rule is a better. First rule. First rule is going to be uh, our kitchen counter will be the location where our protocol takes place. Right. Right. So we live in an apartment. We have a little kitchen. In our kitchen, there's a spot on the kitchen counter, and that counter is where we will go when using this protocol. Right. It's not going to apply in our bathroom. It's not going to apply outside. It will only apply when we're in our kitchen. Second rule: we will use a quarter to store states. So as you can see from the quarter, we can have two states of the quarter. We can have heads or tails. So we know that these two states are what we're gonna be referencing to get information from. The third rule is that heads equals car has been washed. Tails equals car has not been washed. Right. And this is pretty much all our protocol is. Just these set of rules, right? This is an agreement we have with ourselves for how our protocol works. And keep in mind, we have this. This is sort of like embedded in our memory. It's not a short-term thing we'll forget. This is like a long-term thing we've been working with. So we'll remember the rules. So now, consider it's Friday. You have no idea if you wash a car yet. Maybe you did, maybe you didn't. Well, instead of going down 14 flights of stairs to go check, you can just go to your kitchen, look at the counter, and then you'll see either heads or tails. And using the protocol, oh, heads means I washed the car. I don't have to worry about it. And you can go back to relaxing. Tails means, oh, I didn't wash the car. I'm going to go handle that right now. Right? And that's basically what our protocol does. Um, it's very simple, not very complex, not in depth. And I think understanding that this really is all a protocol is really important to not get over your head when it comes to trying to understand other protocols. Um, so I'm gonna to try and like bring this into relevance for more computerized stuff. Which, by the way, information doesn't necessitate electric computers and all that kind of stuff, right? When we're talking about information systems, we're talking about like how we organize information, which usually is how we're organizing states and what protocol we're using to interpret those states into information, right? That's really what we're working with. In this scenario, my whole entire information system is literally just a quarter and my rule set. That's it, right? There's no electricity involved. There's no electrons. There's no capacitors or nothing. Bringing it to computers, I'm gonna kind of map out how computers kind of work in a very abstracted way. We're not gonna go too in depth, but basically, we're gonna use the same concept of using these two states of a coin, and instead of using a coin, we're gonna use bits, right? We're going to go to a computer. There's going to be a hard drive. In that hard drive, there's going to be individual bits which refer to 1 and 0, which literally operate exactly the same way as heads or tails, right? True or false, on or off, heads or tails, yes or no. It's used for the same thing, right? There's two states. The reason why all those different types of way of looking at it are all interchangeable is because what matters is the state, right? You can have two states. So you can have a binary system where you have a bit that's either one or heads or zero or tails. So in similar fashion, using that state, we now are able to have. Let me show some more stuff here. Now we can have these bits, individual bits that each have their own state, which basically could be like a quarter. Like this could be heads, this could be tails, and so on, right? So we have these states of the bits, and the bits are ones and zeros, so it's binary. We just need a way to interpret these states into information. And how do we do that? Well, in computers, the way we do that at pretty much the lowest level is with an ISA or an instruction set architecture. Now, what this is basically so binary is just straight zeros and ones. There's no decimals, there's no indents. It's just a long series of ones and zeros, right? So how do you how do you know which part of the binary code is referencing data and which part is referencing operators and stuff like that, right? That's where the ISA comes in. And what is the ISA? It's the protocol that your computer uses to interpret the data from your states, right? The way we have our protocol to interpret what heads and tails means, the ISA is the protocol to interpret what the ones and zeros means, right? And I'm not going to go into depth about specifically how it does that. I don't know fully myself. I haven't gone too far there. But what's important to note is this basically acts as a protocol, and the bits basically act as states, and that's all you need for an information system, like foundationally speaking, those two things. So now we have a long series of ones and zeros or states, and we have an ISA that can interpolate those states into data that we can use, right? So after after the level up from your ISA and your binary code, usually computers use assembled code, assembly language, right? Which is it's English, but it's still kind of like you need to know how the computer kind of operates to kind of make sense of it, right? If you're just looking at it with no prior context, you're not really going to know what it's doing, right? So assembly language might look like first line here, which does something, and then maybe is a second line here that does something, and so on. And each of these lines references specific portions of the states of your binary code, right? This amount of bits might refer to the first line. This amount of bits might refer to the second line, right? Um, so in this case, your protocol is assembly, right? Let's say you want to go a step up from that. Now you want more readable code. Well, this is where you use like compiled programming languages, right? Let's say you use Java or C++. I'll say Java. In Java, you write out code, um, and it could be you have like your class, and then you have your main method, and then in your main method you have a bunch of stuff to do, functions, blah blah blah. Well, this needs to translate into assembly so that it can then be translated into binary so that the computer can work with it, right? Because the computer only really speaks in ones and zeros. That's why this translation is important. But we don't speak in ones and zeros, which is why we have this higher level language to use for programming. Um, and the protocol here really is the compiler. Compiler. So for Java, for C++, you have your state, which is like, oh, this is what the first line says. This is the state of each character on that line. And then your compiler is the protocol that translates this state into assembly. Take this with a grain of salt. I'm not sure if every single computer might work the same. Maybe it'll go straight from compiled to binary. Maybe it'll go from compiled to assembly to binary. The point being is you have a protocol that takes your state and then translates it into information. And then this information is a state, which is translated into this information, and so on. So when you're learning about protocols and you're dealing with information, understand everything really at its foundational level is just a state, a data state, and then a protocol, and that's it. Your protocol is taking in a state of data. It's probably going to be outputting a state of data or performing some operation or whatever the case may be. But this is really just the foundation of how computers work, which I think is important because, uh, from my experience, uh, computer science is usually taught where you're kind of thrown in the middle of things, which I get why, but I feel like if you want to understand how computers work, starting off with learning how to program in Java might not be the most intuitive start because you're going to have so many questions which could be answered if you had just gone through this kind of line of learning, right? Now, I'm sure that there's a bunch of information between this foundational level and getting up to programming. Like there's a lot of stuff happening in between there as well. But really, everything just kind of boils down to protocols. How do protocols work? We have the kind of like the universal your universal state is going to be like bits, ones and zeros, but the protocols will change, and that's really kind of what we have to learn if you want to understand how computers work on more higher levels, right? Because a lot of times you're going to have systems where you have protocols upon protocols that communicate with other protocols about protocols, and then that whole set of protocols in and of itself is another protocol you have to learn, right? Um, but yeah, this is a kind of my little take on information systems, and I think this is a good starting point for people who want to understand how computers work and learn more about computers. This is probably, if you understand that everything kind of boils down to state and protocols, you should kind of grasp future concepts that you come across to a certain extent. Well, yeah, that's my little 2 cents. Hope you enjoyed.